Hello, everyone. Welcome to today's webinar, the Verta MLOps platform launch. Really excited to have you all here today. Before we get started, just a few housekeeping items. So today's session will be recorded, and we will be sending the recording out to everyone who registered. So you will receive that within the next couple of days. And also your console is fully customizable, so please feel free to move things around and expand or collapse any of the screens on there. And finally, we do encourage you to ask questions, and we will be answering all of your questions at the end of the presentation. So please type any questions that you have in the Q&A panel, and we will respond to those afterward. And at this time, I will turn it over to you, Conrado.
Awesome, thank you. Hello, everybody. Hope everybody's having a nice day. You can ask questions on the Q&A, but you can also access our Slack. We have a couple of colleagues there just available if people want to ask any questions or have any follow-ups. So let me get started. So a little bit about us. So about me specifically. So I'm the CTO at Verta. And before, I was the manager and a lead for the NVIDIA self-driving car efforts. More specifically, I focus on their MLOps platform, MagLab, and on CI/CD, where we ensured every model, every piece of code was validated not only on their specific parts, but also on tens of thousands of hours of data every single day. And before that, I was the lead for Twitter's Cortex, and architect of their current ML platform. So focused both on data science, production training, and production inference. And before that, I've been doing machine learning and infrastructure for many years. So that gives you a little bit of context of like what kind of company we have. And we are the creators of ModelDB. So ModelDB was created by my partner, Manazi, and it was the first model version system ever to come up. And since then, we have seen a lot of other iterations, and we're very proud of the community that we have built so far. But we want Verta to focus not only on what ModelDB solved. We want to focus on AI and machine learning model management and operations for enterprise data science teams. So we still, like, ModelDB still supports regular experimentation and individual researchers, but that's not the focus of the company. And we're going to show a little bit why. So for us, what it means for model management and operations, it means model versioning, model tracking, model deployments, operations, and monitoring. Every single piece that today is pretty complicated for someone to handle, we are bringing the solutions that we know of best in class that have been applied at other companies, but making available for everybody to use. And the main point for us is it's built for data science. We understand that data scientists have a very different set of requirements, so we built for that. But the system is done to be able to run at scale. So what I want to do today is I want to divide into essentially three parts. First, we're going to talk about what is MLOps and what is the Verta platform doing in terms of MLOps and the solutions that we're bringing. And at the end, we have some time for Q&A, just any questions that might pop up from here. So the first question that we have is essentially, why are companies having such a hard time adding machine learning to products? Every single person that has worked at a company that tried to do a machine learning project has seen it fail, has seen at least one project fail for a variety of reasons. And the first thing that people usually think about is the models are hard to train. It requires a lot of deep understanding. And that's kind of the case, but not so much. So today, models are actually very easy to build. Here we have an image from TF Hub. This is just a very short list of all the models readily available. You can just pick up the shelf and run it. We also know that NLP problems are pretty much resolved for most cases. You can, again, go to Hugging Face or many other sources and just pick a model that works. And here we have a basic example for FastAI. You just call the data, you say normalize, create a CNN, train on it, and you're done. So in just a few lines of code, you are essentially done with your model. But anybody that has done machine learning in actual production systems know that what you pick off the shelf is not necessarily exactly the same as you need. So you end up iterating models a lot. based on results and adapting as you go, sometimes even on a notebook. So here we have just shown the first iteration, maybe something that you found online and you copy and paste, and you iterate it again and again, do some changes, and you end up now on your model 50. And it has a pretty good accuracy, and you want to put that into production. The question then comes, how did this model actually came to be? Do you actually remember all the steps? Do you remember if this specific version of the code is the one that created the latest model? So we start to get into trouble on very basic principles of how do we know that the thing that we want to put into production is actually the thing that we want to do? And more importantly, how do we actually put this into production in a robust way? And we depend on developers for that, which means that delivery and operations of machine learning products is the part that is broken. It's not training. We can do that today pretty well. And there are a lot of different stories depending on the aspect. There are people that just keep being blocked on developers. There are people that deploy models, but they don't know if the model is performing well or not. And especially with the current health crisis that has affected a lot of different companies they were just not keeping track of how their models were performing. And when it comes to financial industry, they have a lot of regulations. So they need to know what kind of features they're using and for which purpose, because they need to report all of those. So that's essentially the part that's causing issues for companies today, is picking the model that's already done and putting that into an actual product. And we thought a lot about this and trying to understand why that's the challenge. And what we come up with is, if you think of machine learning, it's a new layer of the software stack. Thinking about the old days, you had like actual machines, hardware, and then eventually virtual machines. And you're talking about specific cables and packets, and it's very raw in terms of compute. Then came the next layer that we're still evolving today with Kubernetes and Istio and like all of these different amazing applications, where you start to talk about APIs, how the systems are going to communicate with each other. What is the service mesh in terms of permissions, retry logic, monitoring, how I'm going to package my information, and we start to converge towards containers. So this layer took many years to evolve and to get to the point that we're in today. But that's not enough, because APIs alone don't tell you the full story for machine learning. Models are not just about which features they get. It's also about which features are relevant, which features correspond to the data that they have seen during training. If your inference data is very different from the training data, we know that can cause issues. So it becomes a higher level up from the usual microservice, where instead of thinking of containers and libraries, we just think, what models do you have available? How do they communicate with each other? How do they transmit data into each other? And what is the data contract of how the data should look like for each one of these? And when we start to think about this problem, there has been some solutions on this space, of course. So you can think, for instance, Kafka, you start to talk a little bit about a data mesh, but it still lacks a lot of solutions. And if you think about it, there is a very basic problem, is everything that we have developed so far for developers is really low level. So if you think about what IT provides today, it provides some very basic tools for you to use. So it provides some networking, hardware, CI/CD, and the developer goes and defines their own pipelines, instruments their own codes with what specific metrics they care about. How does the service going to communicate? Which firewalls it needs to be enabled or disabled? But that's outside of the skill sets of the researchers. It's not something that they're familiar with. So from the researcher point of view, they just want to specify what is the environment that they have, what is the model, what is the data and API spec, what is the SLAs in terms of contracts of data. And the system should just make that work. So the IT should provide a reproducible environment. It should provide optimization for those models and auto-scaling so that the researchers themselves don't need to keep thinking about that and worrying about that specific kind of problem. And the good news is that the whole ecosystem has started to converge to a little bit more higher level application. So auto-scaling is something that some people are already starting to run by default. And optimizers is still something that's an area of research for models. And reproducibility is still a challenge. But we need IT to provide this to researchers. Otherwise, the models created by those data scientists will not have the full quality that we require for production applications today. And as mentioned, the good news is that we kind of have been here before. Not exactly. So if you think about the old days, like 20 years ago or more, we had a very clear separation between operators and developers. And we came to realize that's not a good approach. We need to have developers really owning the operations of their own systems and operators owning the infrastructure enabling developers. So we created DevOps. After a few years, we started to see the same for analytics. So people that wanted to run their queries and understand the data going through. And they face a similar set of challenges. And instead of just the operators running everything for them, they start to focus on enabling the analysts to be able to understand their data. And now we're on the next step, which is MLOps, where data scientists are doing machine learning, creating models to affect decisions of companies, and they're still throwing away models into operators, and operators have to figure out how to make that into a production system, which is not ideal. We need data scientists to really own end-to-end what is going on with their models. So MLOps is essentially DevOps for ML. And what exactly does that mean? So if you think about DevOps, this is a very custom cycle that people should be familiar with, where you have you plan what you're going to do on the sprint, you create, you verify, you run some CI systems, you package, you release that, you build some confidence that it's working, you configure whatever application you have, you monitor that it's working, and based on the result of the monitoring, it helps you plan what are the next things that you should be doing. So this cycle has a lot of tools built for it already. And it's a very rich ecosystem with a lot of solutions focused on different use cases. But when you switch dev to ML, the story is a little bit different. So we can still use the same planning tools, and we have pretty good tools to create models and pretty good research tools to verify models. But when it comes to packaging, releasing, configuring them, making sure that they are always working, it is a question mark. There are different people trying different approaches, but there are a few aspects that are crucial to make this system work for multiple companies. That's why we see a lot of tech companies being able to build in-house, but when people try to replicate that into a generic solution, it doesn't work as well. And that's essentially what we're trying to provide here. We provide a machine learning platform for people to really do their operation cycle of the MLOps cycle. So what it means for us. First, during the creation and verification process, we provide ModelDB. ModelDB has been around. It's an open source project anybody can pick up and use. And the whole focus there is on tracking models and versioning them, making sure that we have the reproducibility tools that we need, and making sure that everything that's done by every team inside the company can be tracked and collaborated with other teams. After that, we focus on deployment, where we manage model releases and we focus on making sure that testing models is safe and deploying them is really fast. And we have been able to reduce the cycle by 10 times by just focusing on how does the data scientist think instead of how an operator think. We're going to have operations, which essentially gives our data scientist customers autopilot for their systems. What this means more specifically is that they are just able to launch their models as an API, and we make sure that it's working on the right versions with the correct autoscaling, the correct robustness, satisfying whatever SLAs that they have specified. And the last piece is monitoring, because again, it's not just about the regular monitoring that we had, it's about the actual data going through the system. And the interesting part of the approach that we have taken here is every part of the system is decoupled from each other. So this means that if you're running, you already have a deployment solution and you have some constraints to move away from that, it's really hard to migrate the whole system at once. So we can do this piecemeal so that you don't need to migrate everything at once, and you can do based on what is your major requirement at the moment. So what this means for companies actually, what can you gain out of doing a good MLOps solution? And this comes from one of our friendliest customers, We really like them. And they had a lot of issues deploying their models. They were blocked on that. They didn't have a good ecosystem before. And they had a list of 21 pain points that existed for the data scientist team. And we actually resolved 20 of them. The last one is actually about their own code development for their own models. So unfortunately, we could not help them on that. But we allow them to move much, much faster, which essentially means that they can deploy a new model in production every single month instead of doing this about twice a year, sometimes just once a year. There is a link at the bottom here if people want to check out the details. We have a whole case study explaining what is the solution that we have done for them and what it means in terms of impact. But what is unique from our approach? Because I bet many of you have heard about different MLOps platforms. And we focus on a few different aspects. First, we need to let data scientists be data scientists. Every approach that's trying to make data scientists into operators and understanding Kubernetes YAMLs or anything like that is missing the point. The goal is not to make data scientists into operators. The goal is to allow data scientists to be leveraged by the companies that they hired for. The second is we need to adapt to pre-existing IT infra. As I mentioned before, a lot of companies have already some sort of solution for some of these problems. And just coming in with a monolith saying that you need to replace everything is not a very good approach. And I have learned this over the years on my previous experience. And we need to make sure that we support whatever is already there, which makes interoperability king. It means that you need to be able to plug and play every single other tool available out there. And it needs to be an API-driven design so that they can also call your specific tools. Of course, it needs to be built for scale and security from day one. If you try to do this after the fact, you are going to get into trouble. And you're going to spend a lot of time just rebuilding your whole system to be able to handle that. And the last piece is giving companies a centralized view of their efforts. Data science is usually silos inside companies. And that ends up creating a lot of duplicated work, which is not ideal for companies. So being able to have a single view of everything that's going on is actually very useful for all of our customers. So demo time. What I want to show here is essentially covering some of these points and some of the cycle. So what we're going to be doing is we're going to find a data set that's relevant for my application. Then we're going to train a couple of models and we're going to compare them, understand what is their difference. Then we're going to pick one model and put it into the registry. That's the first step to move it into production to make sure it is behaving correctly. Then we're going to package and deploy that model. Very simply, just make an API available for querying. After that, we're going to customize the deployment to provide a little bit more flexibility than just raw deployments, the original one. And lastly, we're going to monitor the model and its data, see how it's behaving. We, unfortunately, cannot cover a lot of the things that our system does. And here I have just a short list. Time doesn't allow us to handle everything. But if you're interested on some of this, please contact us or let us know. Maybe we can do another webinar or demo focus on some specific use case. So let's first find the data set relevant to my application. The application that we're going to be doing today is a very basic one. It's the census prediction. It is a tabular data where I want to predict if someone has about 50K of income a year or not. We chose a very simple use case so that we can show how the MLOps cycle actually works instead of focusing on how to develop the best model for some specific application. So let me go to Verta. I have already logged into my system, and I'm going to check my data sets, which unfortunately I don't have any data sets available for me right now on my personal workspace. But let me check on demos. So here I have an organization with a different workspace, which I have already created the data set for it. I could have picked the one that Manesi has created a week ago, or the one that she was working on today, apparently. But let's pick this one. So if I go here, I can really see every single piece of detail about it, so I can understand what this has been done, by whom, what are the versions available for it. In this case, there is only a single version because I prepared this for this specific webinar. So let's load that up. I have here a very simple notebook. I'm just initialize the client, talking to Verta, making sure it's connected. Great. So now I can just set that I want to use this data set, webinar census, and it's going to be on the demos workspace. And I want to get the latest version. Whatever that is, I can just pick it up, which allows me to keep reusing the same notebook. If someone is updating the data set, for instance, adding more examples or fixing some bugs on the labeling, I can just pick whatever is considered the latest version and use that. I could also choose the specific version that I have. Then I'm going to download the data set. In this case, we are only going to need the training and the test part. There are other pre-processed data on the same data set, and we're not going to be using them today to do more in-depth feature analysis. We're going to use the raw original features. So now that it has been downloaded, and just a side note, this is not using Verta's managed datasets, which makes usually downloading a little bit trickier to do. We could have this using on Verta system, but I wanted to show that you don't need to be using Verta to use this piece. This piece so far is just ModelDB. You can get out of the box today. Not as scalable and robust as our managed solution because we handle all the database configuration for you, but you can get it and start working yourself. So in the data sets, and I'm going to load it. Boom. Now I have everything on a data frame. Looks good. I have all my features here. I have here the label that I want to predict. Awesome. So now we're going to go to the next part. Next part for us is training a model. I want to actually train a few models and I want to compare them. So what I'm going to do is just a very small hyperparameter search. You could use a different application to figure out what is the hyperparameters that are going to be better for you. And let me just start running this. While it's running, let's review what the code is doing. So I'm creating a project called Webinar Free Census. I have an experiment called Logistic Regression. Great. Actually, if I go here in the projects, oh wait, I need to go to my personal workspace because I'm operating on my own account now. So I can go here and I can see I have my experiment already logged. And I have a few experiment runs or models already from before. But let's not worry about them right now. So I'm going to create one model. I'm going to do the data set split. This is just using scikit directly. I'm going to log what are the hyperparameters that I have used so that I can know after the fact what is the effects that I have on the results. I'm going to create a logistic regression. I'm going to just train it. I'm going to predict the accuracy on the validation test data set. And I'm going to also log that specific metric. I'm going to save what is a model API and what are the requirements. And this is not necessary just for model development. This becomes important when you're doing actual deployment. So by just providing some examples of what is the input that your model wants and what are some of the outputs, we're able to infer what is the schema of your data and create the API for you automatically. And in specifying the requirements, I'm just saying, this is a scikit-learn model, so I want to be able to use that later on. And you notice that I actually didn't specify any version. I just said scikit-learn, whatever is installed on my system. And we're going to see later how Verta handles that. So I log my requirements. I am also logging my dataset version as training so that I can have a reference to that later on. I'm logging what is my training data. This is used for monitoring. And I'm logging the code information, which means there is a lot of information I'll save it into my model. So I have my hyperparameters, I have the metrics, I have a set of artifacts, and one interesting one is these requirements. So if you remember, I didn't specify a version of scikit-learn, but Verta understands that locking versions is important for reproducibility. So the moment that you specify the library, we automatically capture what specific version you have installed in your system, what specific version of Verta do you have, and what is the specific version of the serialization library that you're using, so that you don't even need to worry about how those things are getting through Verta. They just make it work. And here I have my code version, so I can see I'm using the ModelDB repository on this specific path. Unfortunately, my Git is dirty, so it means that there is change that have not been committed, which is important for us to track, to know if we're able to actually achieve reproducibility or not. And I could click here and go to the specific commits hash on that repository. And I also have my data set. Cool, but what does this mean for us? So let me try to understand what is the models that I have just created. So I can select a few models and I can actually compare them. So I can see that the models have different IDs, as I was expecting. They belong to the same experiment, the same project. They have some different hyperparameters. This hyperparameter is the same across them, so that might be important for me to know. And I also noticed that the model API is the same and the requirements are the same. So this means that all of these models are representing the same thing, and they use the same data set, and they use the same code version. So by looking at this quick view, you're able to pretty quickly assess what is different between the models. So I can see that the validation accuracy here is higher than on this case, and a little bit higher than this other one, which allows me to start understanding what is the effect of the hyperparameters. But you don't want to do that for every single experiment run that you have. So you can also see what is the effect of different metrics over time. So in this case, I just had the logistic regression, and I had run a few times before. So the only metric that we have is validation accuracy. We can group by different hyperparameters, see what is the impact on the final performance. We can visualize the real effects of those hyperparameters and start analyzing them in terms of aggregates instead of comparing every single model one by one. Cool, now I have my model, and I'm just gonna pick this latest one because it seems to have a pretty good accuracy, and I wanna make that one my reference model. So we'll go to the next step. I wanna stage this model into my registry. What this means, so if you look at the navigation bar that we have built, we separate development, registry, and operations. So the registry is the middle step between operations and just raw development. In this case, I already have one specific registry created, again, for the census use case on this webinar. So I'm gonna pick this model. I am gonna register it. I can choose, also I have this one, and I'm gonna give it a model name, V0. So I click this, boom. Now I have all the information from the original model logged again and frozen in time. So I have exactly the same artifacts that I had before. I have a link to my original model that I can open and see what's going on there. And we also establish an approval flow. So when you're talking about putting things into production, sometimes you want to have a specific set of verifications. So what I have set up before is that we need to have a team approval and a management approval. It means that someone from the team needs to come in, say that this is okay to be deployed. Maybe it's your tech lead. And management should at least be aware of what's going on. So in this case, because I own this specific model and we're just doing this for the purpose of a demo, I am going to approve those myself. So I have approved, this is my username, and then I am also approving. And now the deploy button is enabled. We can see that if the model has not been approved yet, we cannot deploy that model into production. So unless it's being verified that it's actually going to behave the way that it's expected, and people are aware of the side effects, the model cannot go into production. Which brings us to the next step, package and deploy. So now it's one of my favorite features, actually, is quick deploy. I click a button, and now it's being deployed. What this means that Verta is picking up the model from that registry. We're going to build a container based on all of the specific requirements that it had with the model. We're going to launch that into our system. So right now we can see that it's building. And again, I have a link back to the specific model registry that I have. And I can see that it's being deployed on this endpoint and it's still building. While it's building, let's see what we have here. So we have this model playground, which unfortunately on this case, I have not filled out any inputs and outputs example. But the idea here is that it allows you to provide the inputs for your model running live and then getting the outputs out of that. Then we have some package formats where you can download the Docker that we have built or the deployment YAML specifying what is going on. I can check my builds, see a little bit of details. Okay, it is the build that I was expecting with a specific number. There is currently no traffic running on it, and the build status is that it's built. Let's see if we already have some logs. Cool. So we already have some logs that are coming in, and these logs are the actual from the models, and we integrate into whatever logging mechanism you have. In our case, we're just running Elasticsearch, but whatever solution you have, we can just leverage that so that we don't need to reinvent the wheel for you every single time. Who seems like the model is healthy? So let me check. Awesome, the model is deployed. Let me run a basic example here. And this model has 43 inputs. So, and I'm not gonna type 43 times this. I am sorry. So 10, 20, 30, 40, 3, I believe. Let's see. Ooh, bad requests. Oh, got 44 features instead of 43. Okay, great. Now we get it. Cool. So for this specific input, my model is predicting 0. So this is essentially just a JSON representation of your table. And if you want, you can just copy the curl command and run in your command line. A lot of teams have found very useful to have this curl to send to their production engineering team to tell them how to actually call their models. So from a curl, they know exactly what is the endpoint, they know what is the method that needs to be used, what is application type, and we also have an access token. So essentially, every model that's deployed can have an access token to make sure only allowed entities can be queried against it. So if you expose this to the public internet, for example, you still need the access token to run predictions against your specific model, which prevents extracting information out of it. We know the machine learning attacks are pretty common these days. Cool. So let's see what we have here. Awesome. It seems like my rollout status is 100% for this specific model. Let's do another deployment. So in this particular case, because I am the owner of this whole system, I can just go to the experiment run. So sometimes you don't want to go through the registry and have the model verified and approach it. You can just deploy something that you're trying out. And that's very useful for development itself. So I'm going to copy my run ID. Let me go to my endpoints. I'm going to update it. Instead of a model version, I'm going to use an experiment run. Unfortunately, we don't have an existing build, so I'm going to have to trigger a new one. And sure, I am going to do a direct rollout. I could do a canary to make sure that the system rolling out is actually safe. So it's not changing the model inputs or giving us any specific errors. I could specify the resource. I could specify environment variables. I could specify auto-scaling. All of that is optional. If you don't choose, Verta will make sure to do whatever is best for a specific system. But maybe your team has some constraints in terms of the operation CM, and we give you that flexibility. So in this case, I'm just going to trigger the output. Cool. So now it's building, and I can see again, it's linking back to my particular experiment run. All right. So it's going to take a hot minute to build. I could, for example, be doing a deployment of a new build of the model version. So let's say there is some change to the specific model version. I can go here and I can select model version 0, V0, or V1. And let's say on V0, I could choose to trigger a new build or use a build that was done before. By using a build that was done before, we ensure we use exactly the same containers and we have full reproducibility also on the deployment system. Cool. So it seems like it's building. Let's see what the monitoring looks like. So we have seen the request before, and this is going to roll over in a little bit, which let me already start. Oh, sorry, I skipped it. The customized deployment I just showed you. So the last one is monitoring the model and its data. So you can see here that there were a few requests going through the model before. But let me just get what is this specific endpoint. And let me go to my Jupyter Notebook. By using Verta, I can just copy whatever is the path. In this case, the path is just a random ID because I need a quick deploy. Of course, I could go and I can choose whatever path I want to have for my specific system. But in this case, we're just going to use the same ID. So I'm going to get the endpoint from the endpoint, I'm going to get what is the model that's deployed there. And boom, now I have something that I can just use from my Python script and call the model. We're going to handle all the authentication steps for you. We're going to make sure that the data is encoded in the right format. You can send NumPy data or data frames. We're going to convert that to JSON for you to make sure everything always behaves correctly. So in this case, I'm going to start seeing the test data set. So I'm just running it with a little bit of sleep so that you can see that happening. And if I go here back to my monitoring, I can see some requests coming up. And we can see that the requests are on the new build. So now we're using the experiment run instead of the model version that I had registered before. And we see the same here, no errors. Before we did have one, but right now we're on 200. And my rollout status, before I was completely on the model version, V0. Now I am on the experiment run. Cool, so it seems like it's running predictions just fine. And latency looks pretty good, throughput stabilizing. So if I'm just using the old microservice layer, this looks pretty good. Like it looks like my model is behaving the way that I expected. My latency is on my SLA, throughput similar to what I was doing. But let me actually see the data going through the model. Okay, there is some difference in terms of my prediction. So my reference said that I should have about this amount on ones and this amount on zeros, which is weird. So let me check. Oh, wow. So this feature, it actually has a very different distribution between the reference and the live data. So on age in particular, it seems like my reference data, the model was trained on, it had people from the ages of 25 up to 50. And now my live data has people over 60 and people below 17. This probably means that my model is not behaving the way that we are expecting it to, because it's outside of the operation range that it was trained on. So using this, I could go and set up a set of alerts that are going to trigger based on this difference, so that my model might not be safe to use in production anymore with just this difference. And in our case, in our example here, the difference came from simply using the test data set instead of the training data set. So maybe this also triggers the information for the data scientists that they might need to shuffle their data a little bit better. Maybe they didn't shuffle it properly, and the test data ended up being very different from the training data. Cool, so based on this, looks like everything was running. I am gonna just stop my model from running, and let's get back. Cool, so this walked us over all the steps we wanted to do for the demo plan. And I hinted about the other parts that we have not covered today because we are almost out of time, so I want to be respectful. So what are the key takeaways that I want to share with you? First, you can choose your language, your framework, or your training process. We're going to fit into your flow. So I chose the Python client. We also have a Scala client, and we have a work in progress on our R client. And the framework really doesn't matter. If you want to have TensorFlow, PyTorch, scikit-learn, anything, we just support it because we're making sure that this ecosystem built is the same one that you have in your machine. So if it runs in your machine, it's going to run in our system. And you can use whatever training solution you already have. And most teams already have some pretty solid training solutions for them. The second is you can do a single click or advanced deployment. Whatever requirements you have in terms of IT, we're going to make sure to satisfy those. So you don't need to worry about them. Verta satisfies those and make sure that whatever your data science team is doing is authorized by IT. And the last one is we provide you autopilot for operations and monitoring. We want to help your data scientist teams to be self-sufficient. They should not be waiting on that. They should not be waiting on operators. They should just click a couple of buttons, run a couple of commands, and things just work in whatever scale is necessary for your specific application. So we have a trial right now, and we have been partnering with some pretty good companies. And I'm excited to share that we're looking for some new partners and trying to evaluate who could really benefit from this kind of system that we will build. We are focusing on this trial on what are the use cases that are really pain points for people and where we can bring the most value, because we know these are needs across many industries. So check out the trial. You can go to verta.ai and right at the front, there is a link to the trial, or you can go to the link below. Feel free to reach out to us on Slack as well. And of course, you can get in touch with me directly, conrado@verta.ai. Feel free to send me an email, suggestions, anything that comes to your mind. And thanks for your time. It's been pretty fun. Do we have some questions?
I was muted. You can hear me now, right?
Yeah, I can hear you now, Julia.
Awesome. Thanks so much, Conrado. We had quite a few questions come through, so hopefully we can get through most of these in the next few minutes.
Awesome.
So I'll just start with some of the most recent ones. Do you have support for training and deployments with GPU?
Yeah, so I mean, coming from NVIDIA, we have run this whole kind of ecosystem on GPUs. So we do support the GPUs for deployment. We currently do not run training for our customers, but if it's something that really pressing need, feel free to reach out to us. We can try to figure out something out. I've been running GPUs in production for many years.
Awesome. And then another one that came through from monitoring part, do you have a way to automatically calculate ML metrics after deployment?
Yeah, so what I have seen, what I have shown today was just like a couple of histograms that is actually coupled with a whole monitoring ecosystem. So you can either use our metrics out of the box, so you have some specific monitors, or you can build your own because there's a lot of domain-specific knowledge. Unfortunately, we didn't have enough time on this specific webinar to cover that, but reach out. I'll be excited to share that.
Awesome. And then someone asked, what frameworks do you support for serving besides sklearn?
Yeah, so for serving, we support essentially anything that you can run in Python or Scala. So we are framework agnostic. You could, in principle, even launch just a Python service with no machine learning application, but that's not the focus of the company. So what we have run before was Annoy, TensorFlow, PyTorch, scikit-learn, XGBoost, TF Hub models that comes with TensorFlow, but they're on a specific set of challenges. Spacey models, I'm blanking out, but like, we have run all the models that we have worked before to make sure that everything works on our system.
Cool. Sorry, just going through because there's a bunch. Let me pick out some here. How is the model op solution different from other similar tools?
Yeah, so it comes back to these key points. And allow me. So a lot of the other solutions, they focus on making data scientists essentially jobs people. So I have seen a lot of them that ask them to define their models on YAML and deploy that and like specify what is the connection dependency. And that's not really what data scientists should be doing. Like that's not a good use of companies' money. So the fact that we want data scientists to be data scientists, but we build the whole infrastructure to be able to plug in into whatever IT system already exists is a key differentiator for us. Because we have been talking to a lot of companies that have tried those other solutions. And for them, it's like a year migration process because it's a monolith. You need to do everything yourself, or you need to expose everything to the data scientists. We think that we can do both at the same time. So we only expose the things that data scientists care about, but we also make sure to work with your infrastructure instead of bringing a monolith.
Perfect. And then another question was, how do you assure model freshness?
Yeah, so model freshness is a constant challenge for companies because freshness means different things for different companies. So the way that we allow this is during our monitoring, and I showed the alerts, you can trigger webhooks. And that webhook can actually trigger a whole training pipeline again. Because all of these steps from Verta point of view are API driven, and you can do them from the Python client itself. You can just run your training pipeline, deploy your whole system, monitor it. Once you see something that's different from what you're expecting, that's going to trigger a webhook, and then this can trigger a new training of a model again. So freshness is up to you to define and how you want to refresh your model.
Got it. And then one more that came through, how does Verta link to cloud platforms if the cloud is deployed there?
Sure. So we run the whole ecosystem on Kubernetes, which thankfully allows us to run on every single cloud provider today, including on-premise cloud providers like VMware or IBM or Red Hat. So in Info, we can deploy anywhere. Not every team has the ops expertise. So we also provide a solution where we deploy Kubernetes for them and manage the whole system. So it is essentially the same as our SaaS, where we manage every single piece. But if you already have an infrastructure that we should deploy on and you're running Kubernetes, you're golden. Should be pretty easy.
Cool. And then someone asked, do you think batch versus real-time prediction is what is required for ML?
I think you need a little bit of both. So there are use cases where doing batch is really the thing that's going to make a difference. So if you're making some predictions offline, for instance, in terms of risk. So what we have learned over the years in terms of like data infrastructure is if you're doing batch and you try to do live, that's pretty hard. But if you're doing live, you can do batch pretty easily because batch is just a particular case of live. So by deploying our system and running against the API, we're going to auto-scale all of that for you. And if you have some constraints that maybe that's not what you want to do, you can actually download the model in a packaged format and use along your application. So let's say you have a Spark ecosystem, and you can download the model and run that through PySpark as well.
One other one, given a model that is stored in your repository, how does an application programmer know what features are to be passed to the model?
Sure. So on the model specification, let me just open here. On the model API, we can see here what are the specific features and what are the specific formats. These specific formats that we have created to be a little bit more flexible due to the constraints of machine learning. But we are also providing Swagger or Open API specifications. And we're currently working with a partner on providing gRPC customized for their use case. Instead of one gRPC for all use case, a gRPC automatically defined for their specific model.
Awesome. And then I think we can probably do one final question. Someone asked, why do we need a new tool stack for MLOps versus DevOps?
Yeah, and that's usually the mistake that people make, unfortunately. DevOps so far, it has two challenges. One, it's approaching up to the second layer. The new layer of machine learning where you actually care about the content of the data and the models themselves, not so much about containers, it is a little bit limiting. And the second is that DevOps, as the name implies, it's about developers. But data scientists, they're not developers. They are not familiar with how to put a system into production, how to monitor it, what is the good approach to satisfy SLAs. So you need a new set of tools and a new set of understanding from people with a different skill set. It's the same reason that before DevOps, we had issues and we created DevOps because devs were very different from ops and they needed a different set of tools. So just saying that whatever works for developers works for data scientists, that's not true. Like models are much more complex. Instead of just code, now you have the environment, which affects the reproducibility considerably. You have the data set, where changing the data sets can change the model completely. And you have the new set of hyperparameters. So models are more complex than most people give them credit if you want to have a production-grade quality.
Awesome. Thank you so much. So we'll go ahead and wrap up, but thank you everyone so much for joining us today. You can request a trial linked out there in your console. So feel free to click there. And then you also have Conrado's contact information linked out as well, and his email if there's any other questions. And we will follow up on anything that we did not get to offline. So with that, thank you everyone for joining us, and we'll see you all on the next one.
Thanks, folks, and thank you, Julia.
Thank you, everyone. Bye.
Bye.